Hey everyone, so these notes are going to walk you through the mole and what the mole actually is and some of the calculations that go along with it. So the first step is just practicing reading a formula and counting how many elements are in that molecule. So it's pretty simple, and we've already kind of been doing this a little bit in class, but you have some examples in your notes. I'm going to do a few of them for you, and then you're welcome to just pause the video and then complete the rest of them kind of, as you go, and then just start the video back again when you're ready. So to get started, let's look at number 1. So this one has a picture kind of drawn out for you what this molecule actually looks like. We know that this is an ionic compound because it's made of potassium, which is a metal. And then we have sulfate, SO4, which is actually a polyatomic ion. So we know this is an ionic compound. That doesn't really have anything to do with counting our molecules, but it's good practice just to recognize these compounds for what they are. So all we're doing is literally counting how many of each element we have total. So remember, these little numbers, that's what tells us how many we have. So in this example, we have 2 potassium. Here, if we don't have a number, we know that it's really an invisible 1. And then here we have 4 oxygen. Okay, so pretty straightforward. For number 2, okay, if we count our phosphorus, we see there's no number there, right? Which means it's just an invisible 1. And then we have 5 fluorine. So pretty straightforward. I'm going to skip over to example number 5 because this one is a little bit different. It has some parentheses. Okay, so we start off the same way that we were in the last one. We have calcium. There's no little number next to calcium, so that means we just have 1 of them. For nitrogen, this 2, we treat it just like you treat a number outside of the parentheses in your math class. This 2 really applies to everything. So it's telling us that we have 2 nitrogen, and then we also have 2 sets of this O3. So it's like if we were to write NO3, NO3, right? If we were to write it out 2 times, we have 2 nitrogens, and then total, we have 6 oxygen. Okay, so we can just apply that little number outside the parentheses to everything inside the parentheses. And we want to make sure that we're multiplying those because we're really saying that we have 2 of that whole thing. Okay, so take a few minutes if you need to practice counting the other examples on your notes. The next step in the notes is really just talking about what is the mole and what it's used for. There is an extra video that's linked on your page of notes if you would like to watch it. It's just a quick little TED-Ed video that kind of gives you a good visual representation of the mole. So if that helps you to understand things, to actually see examples, then it might be a good idea for you to pause this video and then kind of quickly switch gears and watch the video linked in your notes. Okay. So when we're talking about the mole, it's really just a term that we use to tell us the number of something. So just like we say a pair of shoes is 2 shoes, a dozen roses is 12 roses. When we say a mole, really all we're saying
You'll need to continue
is that there's 6.022 times 10 to the 23rd things. Okay, and when we say things, I mean things like molecules, atoms, particles, whatever those little tiny things are that we're talking about. That's how many we have. So it's a huge number. And then you can see right down here, I have that number kind of written out with all the zeros. So you can see exactly how big that is. And it kind of makes sense that there's this many because we know that molecules and atoms and particles, those are all invisible, right, to our eye. A single atom we can't see, right? We don't see the oxygen in the air, right? Those particles are too small for us to actually see them. So for us to be able to really kind of count something or measure something in chemistry, we need a lot of those particles together for us to actually even see it. So it's kind of like, if you were going to go to the grocery store, you don't buy your eggs one at a time, right? It's a lot easier to buy them as a dozen or a half dozen. So we buy them in groups. That's kind of like a mole. We talk about these particles in a group because we can't really imagine one particle because it's so small. Okay, so when we say a mole, it's really just the amount of something that we have, right? The number of things that we have, okay? And then you have this number, the 6.022 times 10 to the 23rd. That's also called Avogadro's number because he's the guy that kind of figured this out, okay? So we name it after him, right? And then we have this little diagram, and it's just showing you that if we want to be able to convert between moles and atoms, we can use this number, Avogadro's number, to help us do that. Okay, so just like if we were to say 1 dozen equals 12, we can say, 1 mole equals 6.022 times 10 to the 23rd atoms. Okay, so we're going to practice using this conversion here in a minute. And then we kind of already mentioned this, but why do moles matter? Why do we use moles? And it's really just to help us group things, right? So, you buy a loaf of bread, right? We don't buy bread by the slice. We don't buy eggs, single eggs. You don't go to the grocery store and count out, your number of slices of turkey, right? You get a pound of turkey. So it's just a way to kind of group things together. So when we're doing mole calculations, if you remember this from kind of the beginning of the year, when we're doing what we call our dimensional analysis, or these calculations, when we set up our problems, we're always wanting to make sure that we're canceling out our units. So remember, whatever's on the top, we want to make sure we put on the bottom so that we can cancel it out, right? So we're going to practice that when we do these first couple of calculations, okay? So just follow along with the first two, and then I'll give you a chance to try some on your own. So remember, we always start, anytime we're doing these calculations, we always start with what we're given. So what are we given? We're told that we have 2 moles of carbon. So I'm going to start out with 2 moles, and I'm just going to abbreviate carbon with a symbol. Okay, and then remember, we start with our train tracks. Okay, if I have moles on the top, I want to make sure, right, that we put moles on the bottom. Okay, and remember now, this is how we're going to convert to atoms. We're going to use Avogadro's number, right, where we said that 1 mole is equal to this many atoms. So 1 mole is equal to 6.022 times 10 to the 23rd atoms. So now the mole cancels out, and then now all I have to do is take my calculator and type in 2 times 6.022 times 10 to the 23rd, and I get 1.2 times 10 to the 24th atoms. Okay, because remember, we always multiply what's on top and then divide by what's on the bottom. Okay, so let's look at the next one for number 2. Right, what are we starting with? we're given the 6.8. 6.8 moles of water, and again, I'm just going to write H2O. So if I have moles on the top, I want to make sure moles are on the bottom. So I have 1 mole, and then I know that in each mole, I have 6.022 times 10 to the 23rd atoms. And again, I'm just going to multiply the top. So 6.8 times 6.022 times 10 to the 23rd. And then divide by 1, which doesn't change your answer. 4.09 times 10 to the 24th. I am not doing significant figures right now, just as we're kind of getting practice with our calculations. We will worry about our significant figures a little bit later on. Okay, so let's look at number 3. We're doing the same thing. We're still converting between a mole and our atoms. Okay, this time we're given our molecules. So remember, our atoms, right? This is where our things are. So atoms, molecules, that's all going to be the same. We're just talking about those tiny particles, okay? So I'm going to start by writing down what I'm given. And this is molecules. Set up my train tracks. And if I have molecules on the top, what do we want to put on the bottom? Molecules. And remember, this is always the number that goes in front of molecules, right? It's where how many things we have. And then it's always going to be equal to 1 mole. So now, when I go in my calculator, I'm going to multiply the top and then divide by the bottom. The trick here is we want to make sure that we're putting parentheses around this number down here, okay? Your calculator is going to get confused when you try to divide it because you're using that times 10 to the 23rd. So we always want to make sure we're using parentheses. So I'm going to do 12.044 times 10 to the 23rd divided by, and then I'm going to type in my parentheses, 6.022 times 10 to the 23rd, close my parentheses, and then that is equal to 2. So we have 2 moles of ibuprofen. Okay, go ahead and pause the video if you want to here, and try to calculate this number 4. Okay, so now I'm going to work it out for you so you can just check your answers. 5.09 times 10 to the 20th. This word formula units, again, is one of our things, so don't let that confuse you. Anytime you see these words that make you think of small things, that's our atoms, okay? So I'm just going to abbreviate that FU. Well, I'll do units. Formula units. And again, we're going to put our 6.022 times 10 to the 23rd because that is what goes in front of all of our small things. It will only ever be 1 mole, okay? I can't have 6.022 times 10 to the 23rd moles. That's way too many, okay? So this number, this big number, can only go in front of those tiny microscopic things. So now I'm going to multiply the top, divide by the bottom. And I get something like 0.000845. Or you could have put it in scientific notation if your calculator does this. Okay, so something like that. either this number is what you got, or this number is what you got. Same number, just a different way to write it. Let's move on to the next section of the notes. So this is something called molar mass. So this is kind of like, think about, we know what a mole is, right? A mole is just a group of things. So when we say the mass, all we mean is how much does that group of things weigh. So it would be like if we took a dozen eggs and we weighed it, right? And then we took a dozen paper clips and we weighed it. Those are going to be different amounts because they're different items. So that's the same way that it works for our compounds, okay, and our elements. This number here, this average mass that we've already talked about before, this is the same, this is how much 1 mole of our sample is going to weigh, okay? So this number is our molar mass, all right? So if I want to know, let's go ahead and kind of look at some of these practice problems as we talk about it. So if I want to know the molar mass of calcium, I'm just going to look at calcium on the periodic table, right? And I'll kind of draw it out so you know what I see. So here's calcium, right? And I know that the molar mass is this number down here on the bottom. So all I have to do is write 40.08, okay? If we're going to look at the next one, right, SO2, so just so you can see what I'm looking at, sulfur, and then we have oxygen. Okay, so if I have 1 sulfur, right, that means the mass is 32.07. And if I have 2 oxygens, that means I have a 16 and another 16. So all I'm going to do is just add those up. And we get 64.07. And this is just measured in grams. Okay, for number 3, we're just going to take the mass of all of these, right, and add them up. Remember, this 2 means that we have 2 nitrogen and 2 of these O3s. Okay, so sometimes the way that I'll write it out is I'll say, okay, we have 1 calcium and the mass is 40.08. We have 2 nitrogens. Each nitrogen weighs 14.01. And then for our oxygen, we have 2 times 3, so that's 6 total. And each oxygen is 16 grams. So now I can kind of, this is me writing out all of this. You do not have to write out all of this. You can probably type all this in your calculator at one time and add it all up. But I'm just kind of showing you my thought process here. Okay, so we're just adding things up. One thing to remember, we did talk about this before, is our diatomic atoms. Remember, these are these elements that always are paired up together, so they're never going to be separate, right? I remember these because I made up a word, and it's Brinckerhoff, so I just sound it out, Brinckerhoff. And you kind of make it sound like you've got stuff caught in your throat, and it sounds funny, and you won't forget it. Okay, so what that means is if we look at hydrogen, hydrogen will never be just by itself. If we say hydrogen and that's all we say, we're always talking about H2. Okay, so if I was to find the mass of hydrogen, then I would want to find two of them. Nitrogen is the same thing, right? Here's nitrogen. If I just say nitrogen, I'm talking about N2. Nitrogen will never exist by itself. It will always be bonded to either something else or to itself. So if we just say nitrogen, we mean N2. So if I wanted to find the mass, then I would just add up two nitrogens. And that is all there is to molar mass.